In this video, I'll be going through question 12 from the 2012 exam. This question involves sensitivity analysis, and you'll have almost all the information you need to do it on the formula sheet. It's just a matter of remembering all the notation that's involved. You'll have to remember what all of the letters in a theorem statement denote, because they're not defined on the formula sheet. The CI values refer to the cost coefficients, and the BI values refer to the resource coefficients. Moreover, we have letters F, E, and K, as well as B star. Each of these correspond to values taken from the final tableau, which I've drawn in full generality on the right here. You can use this as a reference. I'm going to show you where each value comes from when I use them, rather than explain the table on the right here in full. Let's apply this information to the question. In part A, we're asked to find the allowable increase and allowable decrease for some cost coefficients, so that the coordinates of the optimal solution don't change. For cost coefficients, this is covered by the first part of the theorem. To find the increase and decrease for the cost coefficient Ci, we have to know whether the corresponding variable xi is basic or not. Xi is a basic variable if it appears in the leftmost column of the tableau. Once we know whether it's basic or not, we then need to know certain values of E and F to do the calculation. F refers to the bottom row of the final tableau, except for the last value. Then, F1 is the first one, F2 is the second, F3 is the third, and so on. The values for E refer to everything above that. The value EJK refers to the value of E at the jth row in the kth column. Of the box E, which I've put in green here. Let's begin with C1. Applying the theorem, we have I equal to 1, and we have to decide if x1 is a basic variable or not. We can see that x1 does not appear in the left-hand column, so it is not basic. Thus, we use part A of the theorem. The allowable increase for C1 is F1. Which is 5. And there's no restriction on the decrease. Now for C2, our value I is 2. And we can see that x2 appears in the left-hand column. This means that x2 is a basic variable, and we apply part B of the theorem. x2 appeared in row 2, so that's telling us that this j here is equal to 2. To confirm this, you can see that there's a 1 in the second column. Now, to calculate the allowable increase and decrease, we are required to find the minimum value from a set of numbers, which we're going to calculate now. For the increase, we only pay attention to the values in this row where the number EJK is less than 0, or in other words, a negative number. In the row we're currently looking at, this is the only occurrence of a negative number. Now, putting this number into our formula, we have that the increase is the minimum of Fk, which here is F1, which is 5, over the value minus 3, and the minimum of just one value, so the allowable increase is 5 on 3. For the decrease, we look at a similar set of values, instead focusing on the values of E, which are positive. And this next part is important, we only look at the values for which k is not equal to I. This means that we explicitly exclude this value here from being considered. The positive values are 3 and 4, circled here, and the corresponding values of f are f4 and f5, circled here. The allowable decrease is then the minimum of 11 on 3 and 15 on 4, which is 11 on 3. Now we'll move on to part B. To find the allowable increase and decrease for a resource variable, we have to look at the area of the tableau that's underneath the slack variables. Here, our slack variables are S1, S2, and S3, and we're interested in this box here, which will be the matrix K, and this box here, which are the values B star. To find the increase and decrease for Bi, we have to look at the ith column of K. So for B1, we're going to look at the first column. To find the increase, we look at the values in this column which are smaller than 0, which are these ones here, and calculate a fraction using the corresponding values of B, which is this one and this one. So the allowable increase in B1 is the minimum of 63 on minus 6 and 7 on 5, which is 7 on 5. Sorry, that was the increase there. For the decrease, we look at the opposite set of values. We look at the positive numbers and the corresponding values of B. There's only one value here, so we don't need to go through the unnecessary step of writing out the minimum. The allowable decrease is just 24 on 3, which is 8. We repeat the same procedure for B2. The increase is the minimum of 63 on 7 and nothing more because there's no other negative values to consider. 63 divided by 7 is 9, so the allowable increase is 9. For the decrease, we once again go through the same process. We have 24 divided by 4, which is 6, and 7 divided by 1, which is 7, and the minimum of these two is 6. And here we've finished the question.